So last class period, what we talked about was the explaining what is happening to reactants in terms of it gaining or losing oxygen atoms during a chemical reaction. And we call this a reduction and oxidation reaction, or redox reaction. And that's useful, like especially back in the days when people haven't discovered electrons yet, right? And they were trying to explain what is happening to chemicals, I guess, during the course of a reaction, so they can have intellectual conversations, right? But when electrons were discovered, the whole game changed. And so people began to try to use electrons to explain what's happening in a chemical reaction. And no doubt about it, once you understand what's happening to the electrons at the atomic level during a chemical reaction, you basically know how things or how reactants will behave, or how different reactants or reagents behave as they undergo chemical reactions. And if you understand further about the electron behavior of ions and elements, you are able to even predict products without even having to do the reaction itself. So that's the beauty about this. So now we're going to talk about redox, right? We're going to try to explain what's happening to the reactants during the course of reactions in terms of the gain and loss of electrons. So let's start off with a reaction here that has no oxygen. So you can't use oxygen now to try to explain what is happening in. So now without oxygen here, you can't try to explain what is happening to zinc and what is happening to the hydrochloric acid, right? But now you have to think of this in terms of electrons. And before we start this example, pause the video after I talk about the what you need to know beforehand. First of all, you really need to know, have to have a periodic table with you, and you should be able to know the charges of elements as well as things that are bounded in, like here in solution, or ions that are bounded in the solution, and you should know the charges of ions in solutions, okay? So here, I've got a periodic table. Cool. So whenever we have trying to describe what is happening to zinc and hydrochloric acid at the atomic level in terms of electrons, we first have to know the charge of, I guess, the elements. Well, elements in general have a charge of 0, right? So it doesn't matter if, as long as you're an element, you have a charge of 0, and the reason being, you have an equal number of protons and an equal number of electrons. So protons and electrons are all equal. Cool. So zinc has a 0 charge. Now, hydrochloric acid, right? When you dissolve in water, it breaks down into, tilt it down, it breaks down into a hydrogen ion and a chlorine ion. All right? Hydrochloric acid, when it dissolves in hydrogen chloride, when you put it into a solution or into water, it dissolves and becomes hydrochloric acid, which dissociates into hydrogen and chlorine. Hydrogen has a charge of 1. Chlorine has a charge of -1. All right? Cool. So we write down +1 here, and we write down -1 here. All right? So as this is undergoing a chemical reaction, what is happening? Well, zinc is going to displace hydrogen to make zinc chloride. Right? This is a displacement reaction. And when zinc, let's say that. When zinc chloride is made and is in a solution, what is going to happen is that it too is going to dissociate into zinc ion and chloride ion, or just a chloride. Chloride ion is not really a right word because chloride is in fact an ion. Okay, so zinc ion and chloride. And again, zinc, here, you know the charge of here because we studied this in Unit 3, so you should know how to write the charge of zinc. Zinc has a charge of -2, and chlorine is still a -1. So, and finally the hydrogen here, hydrogen being bonded by itself, right? Because it's bonded by itself, it has a 0 charge because number 1 is not an aqueous solution, number 2 is a gas, number 3 is an equal sharing of electrons in its covalent bond. So I got it written all down. So now that we know what's happened, we write down the charges for all this state, we are able to use redox to explain what is happening to the reactants as it undergoes chemical change. So here our zinc, right, it comes from a charge of 0 to +2, 0 to a +2, all right? So what is happening to the electrons? Well, the electrons zinc has lost its electrons, right? Zinc has lost its electrons, right? That's why it has a 2+ charge, because there are more protons than there are electrons. That's why it's a 2+ charge. So zinc lost electrons. And when you lose electrons, you are oxidized. Okay? So when you lose electrons, you are oxidized. On the other hand, hydrogen here, right? Hydrogen has changed. Hydrogen has changed from H+ to H2 with a charge of 0. So what is happening here? Electrons has come into here, the hydrogen ion, and so what we say is that this hydrogen ion here has gained electrons, and so therefore it is said to have reduced. Okay? So that is basically what's happening to here and zinc and hydrogen. Now what about chlorine here? Well, if you look at chlorine, it's basically has a charge of, or chloride, it has a charge of -1, and the chloride here also has a charge of -1. All right? Chloride here has a charge of -1, chloride here has a charge of -1. So it hasn't gained or lost any electrons. So chloride did not undergo a redox process. And so also when this has hydrochloric acid dissociated in solution and zinc chloride dissociated in solution, these chlorides are also known as spectator ions. Okay, a lot of information here, but there is somewhat an explanation of how to predict what is happening to the reactants in terms of the loss or gain of electrons. There is actually a simple and more easier way, but let's go again and talk about another example. All right. Okay. Now that we have kind of talked about an example. Let's throw in another example. How about displacement? Another displacement reaction. Well, it's all the same anyway. So let's talk about iron, the smelting of iron ore. This is a type of iron ore. Okay. And now you can use oxidation and reduction. You can tell me what's happening to iron and oxide by using electrons to explain how electrons are behaving to this reagent to form these products. I'm not even going to balance it because it's not important. So right here, we know that we need to first figure out the charge of this iron, and it so happens to be a charge of 3 from the tips I've talked to you about in class. So we know that the iron has a 3 plus charge, and oxide here has a -2 charge. All right? And so this big elements, iron and oxygen gas, these big elements, it has 0 charge. Okay. So which species is being oxidized and being reduced? Well, because this is an ionic compound, all right? So it has charges in its ions, respective ions. So that's fine. So what is happening to this iron ore? Well, let's write down what's happening to iron. Sounds same. Okay. And what is happening to this oxide? Okay. So for iron, when it has a +3, that means it has a deficient number of electrons, which makes it a positive 3 plus. So what happens is that it actually gained electrons, right? So electrons came in, so it gained electrons. And so when we gain electrons, we say that it has been reduced, right? On the other hand, this oxide has lost electrons, because electrons is at -2 charge, and now the charge is 0, so it went from a -2 to a 0, so it lost electrons. So it is said to have oxidized. All right? So there you go. You can use electrons to explain ionic reactions, or reactions involving ionic compounds, and compounds that are dissociated in solutions, right? Which is really, really helpful, because now we can explain what is happening at the atomic level, or more importantly, what's happening to the electrons as the reagents undergo chemical reactions. Now, what about reactions that don't really fit all these things, all right? Let's say a reaction of burning, all right? So we have burning of methane gas to make CO2 and H2O. I'm not even going to balance these things, because balancing is not the important thing right now. Is to understand what's happening to the reactants. That's important. So here, this methane, well, it's not a ionic compound, right? It's a covalent compound. And, well, when you put this into solution, it's not going to dissociate. It's just going to be methane gas in water. What about oxygen? It's not an ionic compound. It's just a nice covalently bonded molecule that's sharing its electrons equally. And when you put oxygen in water, it just becomes oxygen in water. So how are we going to explain in terms of which part here gained or lost the electrons? Well, this is where the made-up system of redox came in, because now, instead of really understanding where the electrons are, we're going to make believe where the electrons would be if, in fact, carbon will take or give all the electrons, or hydrogen will give or take all the electrons, or oxygen will do the same, right? And to do that, you first need to know a system which is assigning oxidation states or oxidation number. You need to know how to assign oxidation states or numbers. Now these actually have different meanings, but they are representatively the same in most resources that you come across, but they are slightly different, and I will talk more about it next video.